Hi guys, I'm Meena. Today's topic is about integrals. I'm currently studying in Sri Venkateswara College of Engineering, pursuing my bachelor's in computer science with a specialization of cybersecurity. So let's get into the topic. Today we'll be learning about double integrals, properties of double integrals, triple integrals, applications of triple integrals, and the conclusion. Coming to the introduction, it is a study of calculus where we'll be learning about integrals and their properties. Integrations are the reverse process of differentiation. Integrals and differentiations are correlated by the fundamental theorems of integrals. There are two types of integrals, that is definite integrals and indefinite integrals. Coming to the first one, definite integrals, it consists of upper and lower limit. While coming to the second one, indefinite integrals, these does not consist of upper and lower limit. Today, integration is used in a wide variety of scientific fields. And for example, it involves solving of problems in mathematics and physics, such as finding the area under the curve and determining displacement from velocity. Integrals are one of the most important concepts in calculus and double integrals and triple integrals. Now we'll be learning about double integrals. Coming to the double integrals, it is a type of mathematical integration that involves integrating a function over a two-dimensional region. Essentially, it allows us to find the volume under a surface by breaking down into infinitely small rectangles and adding up their volumes. This process can be a bit tricky to understand at first, but with the help of examples and visuals, we can see how it works in practice. To illustrate this concept, let's imagine we have a surface defined by a function f of x comma y is equals to x square plus y square. If we wanted to find the volume under this surface over a certain region, say a square from 0 comma 0 to 1 comma 1, we could use double integrals. We would need to break the region down to the infinitely small rectangles, calculate the volume of each rectangle using height of the surface at that point, and then add up all these volumes. This process can visualized with 3D graphs, and the height of the surface at each point corresponds to the z-axis. Coming to the properties of double integrals, we have two functions f of x comma y and g of x comma y. Then the integral of their sum over a region R is equal to sum of their integrals over the same region. Double integrals R of f of x comma y plus g of x comma y is equal to double integrals R of f of x comma y plus double integrals g of x comma y. This property makes it easier to calculate double integrals to complicated functions by breaking them into simpler parts. Another important property of double integrals is symmetry. A function f of x comma y is symmetric with respect to x-axis if f of x comma minus y is equal to f of x comma y for all x comma y are in the domain. Similarly, f of x comma y is symmetric with respect to y-axis if f of minus x comma y is equal to f of x comma y for all x and y in the domain. If a function has either of the symmetries, we can simplify the calculation of its double integral by taking advantage of the symmetry. Now let's learn about triple integrals. Triple integrals are a mathematical tool used to find volume of a solid in three dimensions. Just as double integrals adding up the area under a curve, similarly, triple integrals are add up the volume under a surface. This process involves breaking up the solid into tiny pieces and summing up their volumes using calculus. To illustrate this concept, imagine a cube with sides of length L. To find its volume using a triple integrals, we would divide the cube into tiny cubes with sides of length dx, dy and dz. We would then add up the volume of each tiny cube using the triple integral formula. This may seem difficult at first, but with practice it becomes second nature. Now, applications to triple integrals. One of the most important applications of triple integrals is finding the center of mass. This involves dividing three-dimensional object into pieces and calculating mass of each piece. The center of mass is calculated by taking the weight average of the positions of their mass. Triple integrals are essential in this process as they allow us to calculate the mass of each piece and its position relative to its origin. Another application of triple integrals is calculating moment of inertia. Moment of inertia describe an object's resistance and rotational motion and are crucial in fields such as physics and engineering. By using triple integrals to calculate distribution of mass within an object, we can determine its moment of inertia about any axis. This information is vital in designing structures that can withstand various forces and torque. In conclusion, we have explored the fascinating world of double and triple integrals and their applications in mathematics and science. We learned that double integrals can be used to find volume under a surface, while triple integrals can be used to find the volume of a solid in three dimensions. We also discussed the properties of these integrals such as linearity and symmetry and their various applications such as finding the center of mass and calculating moment of inertia. It is clear that double and triple integrals are essential tools for solving complex problems in many fields, including physics, engineering, and economics. By mastering these concepts, we can gain a deeper understanding of the world around us and make groundbreaking discoveries that will shape the future. So let us embrace the power of double and triple integrals and unlock the mysteries of the universe together. Thank you. Hope this was informational. Please do like, share, subscribe to my channel.